Crude oil, also called petroleum, is unprocessed oil found deep in the ground. It forms naturally from decomposed prehistoric plants and animals. The color can range from clear to black, the consistency from very watery to very thick. Oil companies drill wells deep into the ground, then install pumping units to draw up the fluid that contains crude oil and salty water. This oil field in Central California has 6,000 producing wells. The pumping units can run 24 hours a day. However, a sensor triggers them to pump only when the fluid flow stops. Here's what goes on inside the well. With each downstroke, the pumping unit pushes a steel rod down the steel tube lining the well. With each upstroke, the rod rises, and the pressure difference between the fluid on the outside and fluid on the inside opens a ball-shaped valve plugging the bottom, letting the fluid flow up the tube. Another valve at the top releases the fluid out of the well. To drill a new well, workers first erect a drilling rig at the site, then hoist a giant pipe with a drill bit on the end. They feed this drill pipe through the center of a spinning disc called a rotary table. As the table turns, the drill pipe turns, its weight bearing down and boring a hole through the ground. Once the drill pipe descends its full 30-foot length, they connect another pipe, then keep repeating with subsequent drill pipes until they bore into the reservoir containing fluid. Throughout the drilling process, they pump a mud mixture down the drill pipe. It comes out the drill bit at the end, hits the bottom of the hole, then backs up to the top, bringing the drilled-out rock with it. After lining the well with a steel tube to keep the walls from collapsing inward, they mount the pumping unit and install the valves we saw in the model. The pumping unit pushes the rod up and down through the wellhead at the surface. As a safety measure, workers take readings to check the air for any hazardous underground gases that may be exiting the well. Once they determine the area is safe, they draw a sample of fluid to test the well's water-to-oil ratio. The typical ratio is 90% water to 10% oil. The fluid from each well exits via a pipe, and the pipes from all the wells feed a main line leading to a gas removal vessel. The fluid contains carbon dioxide, hydrogen sulfide, and natural gas. They naturally rise to the top of the vessel and exit via a pipe which runs to the company's gas treatment plant. There, equipment removes and treats the hydrogen sulfide, transforming it into sulfur, which a local farm buys to use as fertilizer. The natural gas and CO2, meanwhile, are piped to another area, where they fuel the company's steam generator. The generator boils the water extracted from the fluid to produce steam. The company injects steam into the wells to heat the fluid, thinning it so that it flows faster. Once gasless, the fluid is piped to the treatment plant that extracts the salty water. In this big tank, appropriately called the free water knockout, the separation of oil and water happens naturally. The oil floating to the top. However, to hasten that natural process, they add a chemical called an emulsion breaker. The extracted water exits via a pipe leading to the steam generator. The oil goes to a clarification tank in which a chemical process filters out sand, which the fluid brought up from the reservoir. The emulsion breaker added in the previous tank continues to extract water. By the end, when the ratio is 98% oil to 2% water or better, the crude oil is ready to sell. Built-in meters give instantaneous water content readings. As an additional quality control measure, however, the company also draws samples for analysis in its on-site lab. In fact, there's testing throughout production to ensure sufficient water is being extracted at each phase of processing. Refineries buy crude oil as a raw material for producing gasoline, asphalt, plastics, and many other products.